K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about rectifiers and its types. So, rectifier is an electronic component that converts alternating current into direct current, ensuring a unidirectional flow of electric charge. As we know, electricity reaches our homes from power grids in the form of AC, but most commonly used electric appliances such as mobile phones, computers, televisions, fridges, etc. operate on diode current. Therefore, the rectifier becomes a very useful component in electronics. Rectifiers is a electronic device or circuit that converts alternating current into direct current, which is AC to DC. Alternating current periodically changes the direction, whereas direct current flows constantly in one direction. Rectifiers are crucial in many electronic applications where a steady DC voltage is required. Most rectifiers use PN junction diodes to convert AC to DC, but some use different kinds of materials as well, such as semiconductor materials like silicon carbide or specialized semiconductor devices like thyristors and metal oxide semiconductors, field effect transistors. So a rectifier is an electrical device which is used to convert AC current into DC current. Rectifiers thus this process by allowing the current to flow through any device, and the process taking place here is called rectification. Rectifiers works by using diodes which are like one-way valves for electricity. A rectifier can take one or more diodes to convert the positive or negative half cycle of the AC inputs DC output. Rectifiers generates the DC voltage by rectifying any one cycle of the AC supply, and the reverse operation of this above process is called inverter, and the process is called inversion in electricity. So rectifiers play a vital role in DC power supplies for converting AC into DC signal. PN junction diode have a lot of applications, and rectifier circuits are one of the applications of PN junction diode. So in simple words, we can say that the electronic circuit which performs rectification is called a rectifier circuit. So by using the circuit, we can able to convert the electrical signals. So there are various types of rectifiers used in the electronics. So some of them are half wave and full wave rectifiers. So we'll see first half wave rectifier. So the half wave rectifier is a process of removing one half of the input signal to establish a DC level. So here the rectifier conducts a current during the positive half cycle of the input AC signal. During the negative half cycle, the signal is suppressed or clipped. So it is the simplest type of rectifier. So it uses only a single diode to allow the current to flow in only one direction during one half cycle of the AC waveform. So the efficiency of this is relatively low. So this is a circuit diagram of half wave rectifier. So here a transformer is used which is connected in series with a diode and a resistor. So it's very easy to construct. So this half wave rectifier converts the AC signal into the DC signal by passing through the negative or positive half cycle. The only drawback here is that it's less efficient by comparing to the full wave rectifier. In simple words, half wave rectifier produces purely positive by avoiding negative half cycle. On the other hand, full wave rectifier produces purely negative half cycle by changing the direction. So the efficiency of the half wave rectifier is 40.5%, which is considered as low than the full wave rectifier. So here the AC voltages across the secondary terminals AB changes its polarity after each half cycle. So during negative half cycle, terminal A is negative, so diode is getting reverse biased and it will not conduct, so no current flow will be there during the negative half cycle. Current flows only through the positive half cycle. So in this way the current flows through the load RL in one direction. So some of the disadvantages of half-wave rectifier are, since the power is delivered only during one half of the cycle of the input alternating voltage, therefore its power output and rectification frequency is low. Transformer utilization factor is also low here. So the DC output power produced from the half-wave rectifier is not satisfactory to make a general power supply. So there the diagram shows the output of the half-wave rectifier. So frequency of the half-wave rectifier is the same as the input frequency. So this means that when the input AC completes one cycle, rectified wave also completes one cycle. So F out is equal to F in. So next one is full wave rectifier. So in a full wave rectifier, the current flows through the load in the same direction for both the half cycle of the input AC. So this can be achieved by using two diodes. For one half of the cycle, one diode supplies current to the load, and for next half of the cycle, another diode will supply current. So this is shown here, the diagram of full wave rectifier, which has two diodes. So during the positive half cycle, the top diode will be conducting, and during the negative half cycle, that is bottom diode will be conducting, and for both the half cycles you will be getting an output as shown in the figure. So here the output frequency of the full wave rectifier is equal to double of the input frequency. So the F out is equal to 2 into F in as shown in the figure. So this is center tapped full wave rectifier. So in full wave rectifier again we have two types, center tap and bridge rectifier. So this is a diagram of a center tapped. So here we have two diodes D1 and D2 and the center tapped transformer as shown. So during the positive half cycle, diode D1 will conduct, and during the negative half cycle, D2 will conduct. It can be seen that the current through the RL is in the same direction for both the cycles. So this is a bridge rectifier which consists of 4 diodes instead of 2 diodes. As shown in the figure, we have D1, D2, D3 and D4. So here during the first half cycle, 2 diodes will be conducting, which is D1 and D3, and the other 2 diodes D2 and D4 will be in the off state. During the negative half cycle, D2 and D4 will be conducting, and the D1 and D3 will be in off state. So the output will be the same as your center tapped rectifier output. Some of the advantages and disadvantages of the bridge rectifier are, in advantages, it need for a center tap transformer is not needed here, so it's eliminated, and output is twice that of the center tap circuit. And disadvantages, instead of 2 diodes it requires 4 diodes, and internal resistance voltage drop will also increase. It will be twice than that of the center tapped circuit. So hope you understood rectifiers. So let us take up some assessment questions. For a half wave or a full wave rectifier, the peak inverse voltage of the rectifier is always, the answer is smaller than the input voltage. So always the peak inverse voltage is smaller than the input voltage. Bridge rectifier is an alternative for full wave rectifier. Thank you for watching this video.